Alright, let's do the helper video number 8. So we actually have this F atom in the middle, right? And then F actually has a 7 dot, right? So that one doesn't satisfy the octet rule, but F minus, for example, actually have one more electrons, right? So that actually have 8 electrons. And if you actually have the F plus, you're removing one of the electrons, right? So you have 6 electrons. So for this particular case, it's the F minus is the one that's stable. Alright, let's do the next one. So just trying to, alright, just do this one again. Copy this. Okay, then let's do the S2. So for the S2, each S atom is the same column as oxygen, right? So they actually have the 6 electrons like this, right? And then if you actually have 2 of those, 2 electrons in the middle of the in between the S atoms. So if I count the immediate vicinity of this S atoms, then you have 2 electrons there, 2 electrons there, 2 electrons there. You have only 1 here. So total of 7 electrons. So that doesn't satisfy the octet rule. When you actually try to satisfy the octet rule, you really have to satisfy each one of these guys, right? So let's do again. I move these electrons here, and then I move electron here. So what's going to happen there is that you have 1, 2, I'm going to go with this one, just trying to, then that 2 electron is going to have a chemical bond, right? And for this particular case, you have 2 electrons there, 2 electrons there, 2 electrons there, 2 electrons there, so total of 8. And then for the right hand side, that electron also surrounding this S atom is surrounded by 8 electrons, right? So that octet rule is satisfied. Alright, then the next one. What is the general rule of thumb for predicting the type of bond? So let's just say that any atom, type A, so oxygen for example, then you actually form the oxygen, and oxygen forms the O2, right? And then for that particular case, because 2 atom is exactly the same, for that particular case, this is non-polar covalent bond. Non-polar covalent bond. It's just a general rule, right? And then if you actually form the chemical bond in between the 2 different atoms, and for this particular case, it will form polar covalent bond. Oops. Okay, and then let's just say that you have this periodic table look like this, right? And then there is a noble gas. That's a noble gas. Okay, and then if you're combining the element from the left hand side of the periodic table and then right hand side of the periodic table, so for example like lithium and chloride from here, right? When you form the lithium chloride bond between the lithium and chloride, because you're taking it from the left and then taking it from the right hand side of the periodic table, that will form ionic bond. That's ionic bond. Okay, so that's a general rule. Once again, that if you take a look at the videos in the actual lecture videos, then you really have to use electronegativity to actually predict which one is going to be the ionic and which one is going to be polar or non-polar covalent bond. But the general rule is that sometimes it works, sometimes it doesn't. Alright, so which one of the following has a higher boiling point? So lithium chloride, it's going to be ionic, right? And any of the ionic compound will have a very high boiling point. The reason is that lithium is going to carry that any of the ionic bond, one side is going to be having the excess positive charge and then one side is having the excess negative charge. So partially positive on the one side and partially negative on one side. And when you actually have the two lithium chloride next to each other, then that lithium right here and then that chlorine right here having the negative charge and positive charge is going to be attracted to each other by a strong positive negative interactions, and it's going to be very difficult for you to actually separate them. So you're going to have to really heat it up to actually rip off one of the molecules from the rest of the stuff. For that reason, the boiling point is going to be high. Really that when you actually try to boil the water, for example, you're literally ripping off the one of the water molecule from the rest of the body of the water. So yeah, you just need to separate those two. And then if you have a positive negative charge inside of the molecule, it's going to be difficult. On the other hand, for example, like nitrogen, that may not be the single bond, but these two are having exactly the same molecule, right? So there is no charge on the left hand side and no charge on the right hand side, right? So it's a zero charge here, zero charge here. And if you actually try to rip off another nitrogens, then there is no charge-charge interaction here, right? So it's very easy for you to actually separate the nitrogen from the rest of the bodies. So for that, it's easy for you to actually make the gas from the liquid. So for that reason, nitrogen is going to have a low boiling point. Alright, then let's do the next one. Complete the NO3 minus Lewis dot structures. So what we need to do is the NO3 minus Lewis dot structure, right? So putting the least electronegative in the middle and then put the rest of the stuff here, and then this one having the negative charge, right? Each oxygen is going to have 6 electrons, and then I have multiplied by 3, I have 18. And then nitrogen have 5, so total of 23. And then I have 1 extra electrons because the whole thing is negatively charged. So total of 24 electrons, but I already used 6 here. So 18 left, then I'm gonna fill out those empty spots from the outside. Then I used 18 electrons here. Now, if I count the number of electrons for each one of these oxygen atoms, then it's surrounded by 8 electrons, right? So that's no problem there. But problem is the nitrogen. Nitrogen is surrounded by only 6 electrons. So I need to move these two here. So once I do that, then what's going to happen here? I'm going to rewrite the whole thing. So no change there, no change there, and then this will have something like this, right? Now, that satisfies the octet, right? Because nitrogen, you can see that it's surrounded by 8 electrons here. So let's do the next problem, the formal charge. The formal charge for this particular oxygen is in group 6, so it's supposed to have the 6 valence electrons. So 6 minus number of dot minus number of lines, so it's going to have -1. Same goes here, 6. It's supposed to have 6 electrons, or group 6. minus number of dot minus number of lines minus 1. For that, how about this one? This oxygen is going to have the starting out with a group 6, the 6 dot, a 6 dot to start with, and then subtract the 4 dot, actual dot, minus 2 lines, so it has a 0 formal charge. And this nitrogen here have starting out with 5 minus 0 dot minus 4 line, so it's going to have positive 1. So if I add up this positive 1, negative 1, negative 1, and 0, I should end up with a negative 1 charge. So that's how you do the formal charge.